Hey everyone, welcome back to the channel. Today, we're diving into the world of low-level programming with a guide on 8085 assembly language. If you've ever wondered how computers understand our instructions at the most fundamental level, then buckle up because we're about to break it all down. We'll be exploring the architecture of the 8085 microprocessor, like taking a peek under the hood to see how things tick. We'll uncover the secrets behind its features and learn how to speak its language using instruction sets. So, grab your favorite energy drink, get ready to flex those brain muscles, and let's unravel the mysteries of 8085 assembly language together. Alright, let's kick things off by talking about registers. Think of registers like little storage units within the 8085 microprocessor. They hold the data and addresses that the CPU needs to access quickly, kind of like a super-fast RAM. First up, we've got the general-purpose registers, A, B, C, D, E, H, and L. Each one can store 8 bits of data, but you can combine them to form 16-bit register pairs. B teams up with C, D with E, and H with L to handle larger chunks of data. The A register, or accumulator, plays a crucial role in arithmetic and logical operations. Moving on, we've got specialized registers with specific jobs. The program counter, PC, keeps track of where we are in the program's execution. The stack pointer, SP, manages the stack, telling us where the top plate is so we can add or remove plates without messing things up. The flag register signals the status of different operations using individual bits called flags. Understanding these registers is crucial because they form the foundation of how the 8085 handles data and instructions. So, let's recap general-purpose registers for all-around data handling, register pairs for larger data, and specialized registers, each with its unique role. Master these, and you're well on your way to conquering 8085 assembly. Alright, let's talk about the brawn behind the 8085 microprocessor, the Arithmetic Logic Unit, or ALU. This is where the magic happens, where numbers get crunched and logical operations are performed. The ALU handles both arithmetic operations like addition and subtraction, and logical operations such as AND, OR, XOR, and NOT. The ALU works closely with the accumulator, performing most operations on its data and storing results back in it. For example, to add two numbers, one is loaded into the accumulator, the other fetched from memory, and the ALU adds them together. The ALU doesn't work in isolation. It receives instructions from the control unit and interacts with memory to fetch data and store results. Whether dealing with complex calculations or simple logical comparisons, the ALU is the engine that makes it all possible. It's the muscle behind the 8085 microprocessor. Understanding how it works is essential for writing efficient and effective assembly language programs. So remember, the ALU is your go-to for all arithmetic and logical operations. Master it, and you'll have a powerful tool at your disposal. Okay, so we've got our registers to store data and the ALU to perform calculations and logic operations. But how does the 8085 microprocessor know what to do and when to do it? That's where the control unit steps in, like a conductor leading an orchestra. The control unit fetches instructions from memory, decodes them, and generates the necessary control signals to execute those instructions. It's the brain behind the operation, ensuring that everything happens in the right order and at the right time. Think of it like following a recipe. The control unit reads each step of the recipe, one by one, and then instructs the other parts of the microprocessor on what to do. It's all about coordination and timing. The control unit uses a clock signal to synchronize all the operations within the microprocessor. Each tick of the clock signals the start of a new operation, ensuring that everything runs smoothly. The control unit also handles interrupts, which are like unexpected events that require immediate attention. It recognizes these interrupt requests, suspends the current task, and jumps to a specific memory location to execute an interrupt service routine. Once the interrupt is handled, the control unit resumes the original task. So, to sum it up, the control unit is the mastermind behind the scenes, orchestrating all the activities within the 8085 microprocessor. It's the key to ensuring everything runs smoothly and efficiently. Alright, so we've talked about registers, the ALU, and the control unit. But how does the 8085 microprocessor actually access data stored in memory? That's where addressing modes come in. Addressing modes specify the location of data in memory. Immediate addressing means the data is in the instruction itself. For example, MVIA 25H moves 25H into the accumulator. Register addressing uses data stored in a specific register. MOV B copies data from register B to the accumulator. Direct addressing specifies a memory address. LDA 2000H loads data from memory location 2000H. Implicit addressing means the instruction implies the address. For example, CMA complements the accumulator's contents. Understanding these modes gives you control over data access and manipulation. Alright, let's talk about how memory is organized in the 8085 world. The 8085 microprocessor has a 16-bit address bus, which means it can address up to 65,536 individual memory locations. That's 64 KB of memory. Think of it like a giant street with 65,536 houses, each with its own unique address. Each house can store 8 bits of data, which is like having a tiny mailbox that can hold a single letter. The 8085 treats memory as a linear space, meaning that all the memory locations are arranged sequentially from address 0000H to FFH. It's like walking down that giant street, with the house numbers increasing in order. The 8085 can access any memory location directly using its 16-bit address bus. It's like knowing the exact address of the house you want to visit and going straight there. Memory is typically divided into two main segments, the code segment and the data segment. The code segment stores the program instructions, while the data segment stores the program's data. The 8085 uses a special register called the program counter, PC, to keep track of the current instruction being executed. The PC always points to the memory address of the next instruction in line. When the 8085 needs to fetch an instruction, it reads the contents of the memory location pointed to by the PC. Then, the PC is incremented to point to the next instruction in the sequence. So, there you have it, a quick overview of how memory is organized in the 8085 microprocessor. Alright, let's talk about the heart of 8085 assembly language, the instruction set. This is the vocabulary of the microprocessor, the set of commands that it understands and can execute. Think of it like learning a new language. You need to know the words and grammar to communicate effectively. Similarly, to program the 8085, you need to master its instruction set. The 8085 instruction set can be broadly categorized into several groups. First, we have data transfer instructions. These instructions are all about moving data around. You can move data between registers, between memory and registers, and even input and output devices. Then we have arithmetic instructions, which allow you to perform mathematical operations like addition and subtraction. Next up, we have logical instructions, which allow you to perform bitwise operations like AND, OR, XOR, and NOT. Branching instructions are like road signs in your program. They allow you to control the flow of execution, jumping to different parts of the program based on certain conditions. Stack and I/O instructions allow you to interact with the stack and input-output devices. The stack is like a temporary storage area where you can push and pop data. I/O instructions allow you to communicate with the outside world, such as reading from a sensor or writing to a display. And finally, we have control instructions, which give you fine-grained control over the microprocessor. Mastering the 8085 instruction set is essential for writing efficient and effective assembly language programs. Well, folks, there you have it. We've journeyed into the depths of 8085 assembly language, exploring its architecture, registers, instruction set, and so much more. I know it's a lot to take in, but remember, even the most experienced programmers started right here, one instruction at a time. If you found this guide helpful, give it a thumbs up, share it with your friends, and subscribe for more deep dives into the world of tech. And hey, if you've got any burning questions or topics you'd love to see us cover next, drop a comment down below. Until next time, keep on learning, keep on building, and keep on pushing the boundaries of what's possible with technology.